Let's do a couple more examples when we are done. So let's take this circuit. We have an NMOS circuit, and we want to find I sub D and VDS. Again, you have to look at the circuit, make an intelligent guess. Either it's going to be in saturation, ohmic, or cutoff. I'm going to assume saturation here because this will definitely be in saturation. And again, if I assume saturation, there are two conditions I need to validate: that VGS is greater than the threshold voltage, and VDS has to be greater than VGS minus the V threshold. Well, I know the voltage here, VGS, this is the source, this is the gate, this is the drain. What do you notice about this circuit? That the voltage for the gate and the voltage for the drain are the same. VG is equal to VD. That means VGS is going to equal to VDS. And if this is 10 volts, I guarantee you this is bigger than 2 volts. So let's go to this one. Since these guys are equal, and you want to subtract from this number 2 volts, this definitely will be bigger than this all the time. So I know definitely I'm in saturation. Why? Because these numbers are equal. I don't care what number you choose. Choose 10 for them. Is 10 bigger than 10 minus 2? Yes. Choose 4. Is 4 bigger than 4 minus 2? Yes. Choose 7. Is 7 bigger than 7 minus 2? Yes. So this is always true. So definitely this is in saturation. No guesses, nothing on it. Now I'm going to find I sub D. When you're in saturation, I sub D is equal to what? K times VGS minus the threshold voltage squared. So if this is 10 volts up there, then this voltage here is 10 volts. So VGS is right there. So let's look at the math. VGS is equal to VG minus VS. VG here is 10. Take away VS. What's VS here? 3K times I sub D. And I sub D is 1 milliamp. The millis and Ks will cancel. That's 10 minus 3 I sub D. So if I go to this equation here and now do some substitution, K I use for this example 0.2. VGS is 10 minus 3 I sub D minus the threshold, which is 2, and square it. What's 10 minus 2? 8 minus 3 I sub D. FOIL this one out. 64. 3 times 8, 24. 24 times 2 is 48 I sub D plus 9 I sub D squared. If I divide both sides by 0.2, just to get rid of that 0.2, because I don't like to have decimal values, 1 over 0.2 is 5, or multiply both sides by 5. So if I reshuffle everything, 0 equals 9 ID squared minus, what's 48 and 5? 53 plus the 64. And let me divide by 9 just to make the number a little bit smaller. This will be I sub d squared, and I will just carry only a few decimal places. 53 divided by 9, 5.9 I sub d. 64 divided by 9, 7.1. Can we solve for I sub d? (5.9) plus or minus the square root of negative 5.9 squared minus 4ac divided by 2. Small table I'm sitting on, so there's not much space to put things. 5.9 square minus 4 times 7.1, 6.41, take the square root of that number. So I have 5.9 plus or minus 2.5 roughly divided by 2. So one solution is going to be I sub d 5.9 plus 2.5 divided by 2 is 4.2, and the other one is going to be 5.9 minus 2.5 divided by 2. It's 1.7 milliamps. Again, I wrote VGS equals to that equation. So let's look at each one of them. If I sub d is equal to 4.2, if I use the 4.2 milliamp, what is my VGS? It's going to be 10 minus 3 times 4.2 10 minus 3 times 4.2 is negative 2.6 volts. And if I use I sub d equals 1.7 milliamp, VGS is going to be what? 10 minus 3 times 1.7 it's going to be what? 10 minus 3 times 1.7, 4.9 volts. Remember what my assumptions are. You want VGS to be bigger than the threshold voltage, bigger than 2 volts. So this cannot be. That's the only one that makes sense. Now, I satisfied one of the conditions right here. I also need to satisfy this condition to prove I'm in saturation. I need to prove that VDS. So this is my current. I'm using this for a current. I'm using this for VGS. Let me see if I can find VDS. Looking at that circuit again, straight down, 10 equals VDS, the voltage here, plus the drop there, plus 3K times I sub D. 10 equals VDS plus 3K, and my I sub D here, I'm using what for I sub D? 1.7 milli. So what's 3 times 1.7? 5.1. VDS VDS equals 4.9. So let's see if my second condition is true. Is my VDS bigger than VGS minus the threshold voltage? My VDS is what? 4.9. Is that bigger than VGS, which is, I have that somewhere. Where was it? On the next page. 4.9 down here. Minus the threshold voltage that was given to us to be 2, and that's yes. So my assumption is correct. My numbers are good. So here are my answers. This is my VDS. That's my VGS. This is my I sub D. And my assumption is correct. And that problem is done. One more. I know you guys are tired, but give me a minute here. Let's see if I can find a neat problem. I'm just thumbing through the book to see if I can find some cool problem just to wrap it up, finish it. And it looks like our book is wimpy. They don't want to give us cool problems. I don't see anything to brag about, so I'll just take one more since I said we'll do one more. And I'll give you that one. Okay. Let's design the circuit. Design the circuit. At right. When I say design here, that means you have to choose K for the NMOS and also R sub S. I'm going to choose both these so that I sub D is equal to 1 milliamp and VDS is equal to 2.5. I think the pen is dying. Let me get a different pen quickly. Okay. And here's my circuit. Six volt. R sub S. And I'll make this, I don't know, 5 volts VGS. This is I sub D. This is VDS. So I'm giving you VDS here in the example equals 2.5. The question is, what is this value here and what's K? Well, if you write mesh equation down, we have 7 volts equal VDS minus, or plus here, R sub S times I sub D. Well, that's the first solution. We've given you what VDS, it's 2.5, so 6 equals 2.5 plus R sub S, which is unknown, and I sub D, which is 1 milliamp. So let's do the math. 6 minus 2.5, 3.5 equals 1 milliamp times R sub S. You do the math, R sub S will have to be 3.5 kilo ohm. So we got one problem done. And if I know what that is, can I find what, this is S here, can I find what this value, what VS is? VS should be 3.5 volts. It's the 6 minus the 2.5, which is the 3.5. And this is VG here. This is VS. So I know what VGS now. It's VG minus VS. What's my VG? My VG is going to be 5. And what's my VS? That's 3.5. And what do we have? We have VGS to be 1.5 volts. I forgot one thing to give you in this problem, that the threshold voltage, you get that from the data sheet, the threshold voltage is 1 volt. I forgot to write that. So let's see what mode we are in. Is VGS bigger than the threshold voltage? That's 1.5. Is that bigger than 1? Yes. So that this NMOS is actually on. But is it ohmic or is it saturation? Let's see if it's saturation. Is VGS or VDS bigger than VGS minus the threshold? VDS, that was given to you to be 2.5. VGS, we just calculated that to be 1.5. The threshold voltage is what? 1 volt. And is 2.5 bigger than 0.5? That's also a yes. So yes, we have saturation. If I have saturation, I know what the current is. I of D equals K times VGS minus the threshold voltage squared. I sub D, I found that, or that was given to us to be 1 milli. K, VGS, we know what that is, 1.5. The threshold voltage, that happens to be 1. 1 milli equals K times 0.5 squared. You square the 0.5 is 0.25. And what is K equal to? Divide by 0.25, 4 milliamp per volt squared. So this problem, we worked it backward. I gave you the other information, and I was looking for K, and I was looking for R sub S to design it to meet that criteria there. And it wasn't really that difficult. It's much easier than the ones we did before, because the current equation becomes much easier to solve than quadratic. But again, I forgot to give you the threshold voltage in the problem to be 1 volt. And I think that's enough with these videos. So good luck, and I will see you in the next one.